Okay, today we're gonna look at why cheap Chinese multimeters are not very good. About 80 milliamps here, 273 on the UT120C. What's going on? That's simple. This is a piece of Chinese garbage. So what's going on here? Where are the shunts? Let me set it to the microamps range. As you can see, R17 is the microamps current shunt. Milliamps, it's R16. This is a 99 ohm shunt, and the R16 is a 1 ohm shunt. So how are these protection diodes connected? Set it to microamps. Well, straight to R17, right? If I switch it to milliamps, they should be connected to R16, right? What's going on there? Well, the protection diodes are not being switched between the two shunts. Okay, let's see if they maybe had a spare set of contacts that they could have used to switch the diodes between the two shunts. As you can see, the range switch has all 4 pairs populated, and the PCB does have a pair of contacts right here that are not being used. As you can see, these 2 pairs right here are being used to switch the current ranges, and these are the unused contacts I'm talking about. So this is what's going on. The range switch is changing between both ranges. The microamps, you get 100 ohms through both shunt resistors. Milliamps, you only get the 1 ohm resistor. Oh, I forgot the fuse. Oh well. And the protection diodes are connected to the microamps range. So if you cause a short circuit through the milliamps range, this shunt resistor could potentially suffer. So what would I have done in this case? This. Please forgive the absence of the fuse. If you would have used one set of contacts to switch the input into the current ranges, have the protection diodes right here, and then use another set of contacts to connect the shunt resistors. You might also note that I'm only using 2 diodes in this case. Let's go into why. So let's go into the voltage being dropped on both ranges. First we got 400 microamps times 100 ohms, right? This is 0.04 volts. And on the other one, well, it should be quite obvious that it's 0.4 volts. In both cases, you won't reach the forward voltage of more or less 0.6 volts of a normal silicon diode. So it wouldn't be a problem to only use 2 diodes. Let's go into the power calculations as well. For both 1 and 2 diodes. In this case, we're using they're using MELP resistors, which should be able to dissipate about a watt. Okay, so let's pretend that we're getting 0.7 volts across a 100 ohm resistor. 0.7 divided by 100, that should give us the current. Wait a second. 0.7 divided by 100 should give us the current, times 0.7, that should give us the total dissipated power. I'm assuming 0.7 volts to err on the side of caution here. Again, 0.7 squared divided by 1, about half a watt. What happens if instead of 0.7 we use 1.4? volts? As you might expect, you're going to get twice the dissipated power. And in the case of the 1 ohm resistor, it would be dissipating twice its rating. This is why I will only use 2 diodes. And this is something I find odd, because designing it right would have been slightly cheaper. Anyways, just for the fun of it, let's measure the value of this brown 1 ohm resistor, which is clearly no longer 1 ohm. And of course, I'm going to use this opportunity to salvage the most expensive part on this board. Also, you might be wondering if there's a way in which this board could potentially be salvaged. Say if you have one of these and you either had this problem or decided to source a new resistor, or haven't had this yet but want to make it slightly more rugged so this won't happen to yours. What would I do? Well, that's very simple. Add a butt wire between both diodes up here, connect this to the ground plane in there, cut these 2 traces, and add a second butt wire to these resistors like that. Effectively, both resistors now have overvoltage protection, which should prevent this particular failure. Okay, so how exactly did I fix mine? I didn't. I got myself one of these. Sure, it doesn't measure current, but everything it does it well. And I know for certain that this thing is not going to drift because of a mistake like this one did. And this is why I seriously dislike Chinese junk.